in the previous video we saw that the formula for the position as a infinity sum is the summation from n equals 0 to, we could say, infinity of the derivative n of the position, so r of t, with respect to time, t to the nth power divided by n factorial. We saw that this is r is equal to the zero derivative, it's just we don't take the derivative, so it would be just r of t. Here to the 0 is just 1, divided by 0 factorial is 1, plus the first derivative, let me put it as r prime, t to the 1 power divided by 1, plus r prime prime of t, t squared divided by 2 factorial, plus r prime 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 of t cubed divided by 3 factorial, plus r prime 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 prime, I think that now I put 4 here, of t to the 4th power divided by 4 factorial, that is 24, plus the 5th derivative of r of t to the 5th power divided by 5 factorial, plus the 6th derivative of r with respect to time, t to the 6th power divided by 6 factorial, and so on. In the previous video we just saw until the 6th derivative, because we have but there are many more, the 8th, the 7th, 8th, 9th derivatives of position, we can also add them. And so it would be the 7th derivative of t to the 7th power divided by 7 factorial, and the same, so on. So here we saw that this is the position is equal to the initial position plus the velocity, original velocity times time, plus 1/2 of the acceleration times square, plus 1/6 of the jerk, t cubed, plus 1/24 of the snap, t to the 4th power, plus 1/120 t to the 6th power, to the 5th power, plus 1/720 t to the 6th power. Times, sorry, here times the Clark and here times the Pop. Crack. So, anyway, you can ignore this because here this is the part that we care about. So now remember that Taylor series has the shape of f of x is approximately equals to f of a plus f prime of x evaluated at a, so f prime of a, times x minus a plus f prime prime of a, x minus a squared divided by 2 factorial, plus f prime 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 of a times x minus a cubed divided by 3 factorial, plus f, the 4th derivative of f evaluated at a, x minus a to the 4th power divided by 4 factorial, etc. So it's exactly the same shape that we have here. So we have f, that is r, f prime is r prime of t, here we have x minus a, and this is because this is the Taylor series. If we this a means at which point we are centering Taylor series. So if we center Taylor series at 0, we have that f of x would be approximately equal to f of 0, that is the original function, f prime of 0, x plus f prime prime of 0, x squared, because I'm centering it, when a is equal to 0. So I'm centering at 0 divided by 2 factorial plus f prime 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 of 0 x cubed divided by 3 factorial plus f the fourth power of f evaluated at 0 x to the fourth power divided by 4 factorial, etc. So if you see here, well, here we can put it as 2 factorial, 3 factorial, 4 factorial, 5 factorial, and 6 factorial. So if you see, we have the position S of x or R of x is equal to the original position plus the original velocity times the time. Here x in this case is t, and f of x, I mean r of t, or whatever we want to call the position vector. So it's the first derivative times time, the first derivative is the velocity, plus 1/2 of the acceleration times the time squared, plus the third derivative, that is x over 3 factorial, that is 6x cubed, etc. So this formula that we came up on the previous video corresponds to this Taylor series, and here specifically the one that we use when we say r is, or position is equal to the original position plus original velocity times time plus 1/2 of the time acceleration time squared, that then we can add plus 1/6 or 1/3 factorial x to the times t cube, etc. This corresponds to the Taylor series for the position centered at time equals 0. So in our original time, centered at t equals 0, we have this, that is exactly this.